Okay, change.
So can you see my screen?
Yes.
Excellent. It's always good when that works.
Yes, absolutely.
Well, hi all, this is Doria Gordon, and you just heard me introduced, and I'm happy to be here today to talk a little bit about some work that we've been doing recently using both current status and predicted status to try and understand these tools and how they might help guide management decisions. And so I'm doing this work with Dia Lawrence and Luke Flory from the University of Florida. So they are my co-authors, and you see their names on this first slide. And I'm going to talk about vines, but I now have increasing experience. We now have increasing experience working with a lot of different groups of species. So if you have questions about other types of species at the end, we can certainly hit some of those as well. What I'm going to do is, by way of this, in this next 45 minutes or so, is to give you just a little bit of motivation for why we should be thinking about climbing vines in specific when we are trying to make predictions about which species might be troublesome in natural areas and in other systems as we move forward. I'm going to give a little bit of an overview of both the status and the predictive assessment that I've been using, so you just understand the tools that I'm going to describe. And then I'm going to talk to you about what we're learning about climbing vines, non-native climbing vines in Florida. So just why focus on vines? Well, it turns out that vines are more likely to be invasive than a random species from some other group or growth form, and in particular climbing vines. So this is work that Kurt Dollar published in 1989. It's really a great widespread looking across all families and growth forms. But if you look at what I have outlined in red here, what you can see is that families that have some climbers have a higher proportion of natural area invaders than families with no climbers. So climbing vines are a real issue and disproportionately predict invasiveness. In other words, more of them are going to be invasive than in natural areas than species with other growth forms. And secondly, what we know from work that was done in Florida was that, which confirmed sort of the prediction that Kurt Dollar made, which is that about a third of introduced vines have naturalized in Florida, whereas the number is lower for other growth forms. So both of those pieces of evidence made me start thinking that we probably ought to be paying more attention specifically to vines than I had been paying in the past. And I'm going to just show you a little bit of information that's not specific to vines, but is specific to the fact that we are continuing to import new species. So this is USDA data from 2004, and you can see that between 1995 and 2002, the number of plant shipments doubled, the number of plants within those shipments increased dramatically, the volume of imported seed doubled, and you may wonder why someone working in Florida is so sensitive to this, and that's because Florida, this is the port of plants imported through the port of Miami, through the Miami International Airport specifically, a little bit old data right now, but you can see this exponential growth, and it's very indicative of what's going on in the U.S. because 85% of all plants imported to the U.S. enter through Florida. So that's huge because not only are we sort of ground zero for species being imported, but also they're being imported into a very hospitable climate relative to other places, other port cities to which they could be imported. It means that an escape here is more likely to get established, all else being equal, than escape somewhere else. And this, of course, is, I'm talking about plants, but put your favorite taxonomic group in here. A lot of pests on those plants, a lot of animals in the animal trade. We're a very hospitable environment in which to enter the country. And lastly, what we know is that the imports are continuing to increase. And this is particularly relevant because preventative tools, like the one I'm going to talk to you about, are not terribly useful for if everything coming in is coming in by accident as a contaminant or unintentionally. But what you can see is we have very deliberate imports of plants. As a result, we should be able to ask the question at the border before they actually get in, do we want this thing here? Right? That's the real goal of a preventative tool. And just in case you weren't convinced a minute ago by what I just told you about the numbers of things increasingly moved around, this is the Earth at night, and you can see the shipping and transport lanes that are global now as they are lit up at night. And it was really interesting that there was just very recently a paper published by Humer et al. In 2015, and they looked at eBay and 9 other online auction sites. And they tracked the number of plants being traded through these online auction sites for 50 days. And they documented that in those 50 days, there were over 2,600 species sold in 65 different countries, all of those online. And more than 500 of those species were documented invaders in some region. So, you know, we are moving things around at an incredible rate. That was just really dramatic to me when I read that very recently. So there's the online flora trade, and it's moving through these same pathways that you see on this outline of the globe. Okay, so let's come back down to ground about Florida. This is going to be the heart of what I'm going to talk to you about. So the first question was, you know, once I was sort of thinking about this documentation that climbing vines are disproportionately likely to become invasive, then the question was, well, how many non-native climbing vines do we have in Florida? And the answer is almost 100 that we know about, which is a pretty big number, actually. There's 100 different species. So what we have, and I'm going to tell you about the tools in just a minute, but we have in this data set that I'm now going to talk to you about, we have 90 species for which we know something about their current status in Florida's natural areas and other systems. Of those 92, we have 89 that we have risk assessments for, and the ones we don't have risk assessments for, it's because we don't have enough information on them. We're still looking. We couldn't complete the risk assessments. And then just as a little piece of background that I'm going to come back to, about 3/4 of those species have been in Florida for more than 50 years, so they have a pretty good history here. And you can see when I tried to just split them into growth habit, and there's overlap here, you know, so some of them are herbaceous, perennial, evergreen species, and they get a tick for every one of these boxes. But just so you can see, the majority of them are perennials. And not all of them, I would have thought in this climbing vine sort of game that most of them would be woody, but that's not true. A lot of them are not woody, but they are perennials. A lot of them are evergreens. So just to give you a little bit of a feel for the species that we are going to talk about. Okay, so looking at that list, I just dealt with 4 hypotheses. One was that a high proportion of introduced climbing vines would be predicted to be invasive in Florida, and we would see them as invaders in Florida. The status would be that they are already invasive, and so that the predicted risk of invasion is reflected in the current invasion status. For whatever reason, I had thought, but I turned out not to be quite right, that woody species are more likely to be invasive than non-woody species, just I thought because they would maintain so much of that tissue that they wouldn't have to keep regrowing into the canopy or from, you know, if they were not woody. And that invasion status is correlated with years in Florida. I'm just going to review for you the evidence for each of these hypotheses, but I'm going to start by talking to you about the tools we used. So to get an idea about the current status of species in Florida's natural areas, we used what is the University of Florida's Institute of Food and Agricultural Science, that's the IFAS there, status assessment. This is, I've given you the URL, and you can look up essentially any non-native plant that you can think of, and hopefully if they're in Florida, they are in this database. And this was really asking the question, not might this be a species that would be invasive or that could get more invasive. The question was, is this a species that, based on its current status in natural areas, that we actually think is a harmful invader or not. So, and there are a series of questions. They're based on the distribution of the species, current distribution in natural areas, potential for ecosystem impacts, how much they reproduce, whether they're easy to manage or not, and how much economic value they have. We did this assessment working with the horticultural industry. One of the queries the horticultural group really wanted us to think about is to divide the state into regions, because we have a really subtropical South Florida and we have a more temperate North Florida, and there are a number of species that are invasive in South Florida or have the potential to be invasive in South Florida and have less potential to be invasive as what gets into cooler and freezing temperatures in North Florida. So for each species that's assessed, it's assessed independently for each of those three zones, and the conclusions that are drawn is that this is a species that does not appear to be invasive in Florida's natural areas. It's a species that the caution is it looks like it might be becoming invasive. In other words, we see it in natural areas, but its point scores associated with the questions were not high enough to conclude that it's really having ecosystem impacts at this time, but we're worried about it. And this happens sometimes for species that, for example, are invasive in South Florida, and they're only at the edge of Central Florida. We're going to give that a caution, because it might be moving further north over time. And lastly, this is a species that the conclusion is that it's invasive. This is a species the University of Florida would not recommend for use. So that's the status assessment. But that isn't sufficient for the current status for the purposes of the test that we were doing here, because the predictive tool, which I'm going to talk to you about in a minute, isn't only about invasion potential in natural areas. It's also about invasion potential in agricultural systems, in disturbed areas. So we have to have another way to get at that status component. So in the end, we used 4 ways to identify species that we're going to call current invaders. Either they come out as caution or invasive in natural areas using the IPC assessment that I just described to you, or they're actively prohibited species in the state of Florida by the Florida Department of Agriculture and Consumer Services, or, and this is, we were trying to get at species that might be in disturbed areas, species that might be more rapidly than we, that might be on, really being invasive rather than just being mixers in. So we decided that since, in fact, it's relatively rare for people to collect herbarium specimens, if it was a species that where we had herbarium specimens for more than 5 counties in Florida, or more than 5 herbarium specimens from any one county in Florida, meaning it could be just a local that's getting pretty big, but it was only introduced in that one place. For any one of those reasons, if the answer is yes, then that's a species that we said was currently invasive in Florida's natural system. In Florida. So it's a pretty wide net, and it's hard to know, and it's something to ask, and that we're going to continue to ask, whether this more than 5 counties, more than 5 specimens from any one county is a good surrogate for, is it invasive in Florida along roads, for example, which we might not pick up in other ways. All right, so that's the status. And then to talk to you about the predictive tool, and I apologize for those of you who might have heard me talk about this before. The predictive tool that I've been using is totally derived from the Australian Weed Risk Assessment, which was published by Paul Fallon and others in 1990. It's a tool that now has had more than 20 years of regulatory use in Australia and New Zealand, so it's relatively well understood. And when it was tested in other locations, so it was tested right as I was starting my work against 2 other methods that had been suggested for risk assessment for plants in Hawaii and the Pacific Islands, and then also in the Czech Republic. And those were great places that people tested it, because we had a tropical island situation, we had a temperate continental situation. What they decided was this was the most accurate tool. And when people test it, including when I've tested it, the way you do that is you have to use something like the status assessment. You have to have some way of judging which species are invasive and which species are not invasive. So you have to have at least those two groups. And then ask the question of whether, if you knew nothing about the action of that species in the region of interest. So if you're trying to validate the model in Florida, you get a list of species that you know have been introduced for some period of time, some of which are invasive, some of which are not invasive. Then, ignoring all data from how they behave in Florida, you ask, if it were essentially a pre-border test, would we have predicted how these species did in Florida, given that we're not using any information from the place? So it's a retrospective look. In other words, the species have to be in the location long enough that we understand if they're invaders or non-invaders. And of course, in the non-invader category, these always could be species that are just much more slowly invasive. And that's why you expect this not to be a perfect model, no matter how well you do. But when tested in the Hawaiian Pacific Islands and in the Czech Republic, this Australian weed risk assessment seemed to work really well. So that's when we decided, to use it in Florida. But before I tell you that, I will tell you that what it is. It's a pretty simple tool. It has 49 yes/no questions that cover areas of history and biogeography, use of the species and its distribution, and areas of biology and ecology. So a bunch of traits. And each of those 49 questions has a point score associated with it. Most of them are yes/no questions, like is it dispersed by wind, for example. And a yes answer would get a positive point score associated with it. A no answer would get a negative point score answer with it. You don't have to answer all 49 questions, but you do have to answer at least 10 in a stipulated distribution among the 49 questions. And to that effect, we could answer, we almost always can answer somewhere over 30 questions per species, and don't usually have trouble with not having enough information, although as you saw in the beginning when I told you about the vines we were working with in Florida, there are about 5 or 6 species for which we couldn't right now finish the assessment. So for the species that you've answered more than 10 questions in that stipulated way, you sum the point scores associated with all the questions, both positive and negative. And if the number is less than 1, that total score, then the implication is that this is a species that's a low-risk species for invasion. It's likely not to become invasive. If the score is higher than 6, it's a high-risk species and therefore is one to be avoided. And in Australia and New Zealand, when a species like that is proposed for introduction, and they do this as a pre-border test, and it comes out to be a score higher than 6, the answer is no, you may not bring it in. That's not how a risk assessment works in the U.S., but that is how it works in those countries. If the score is between 1 and 6, it means you need more information. And in Australia, when you need more information, you can't bring it in until you can demonstrate that you have that additional information and it turns out to be a low-risk species. In many other places, a species that needs further evaluation would be allowed to be, moved around until we know better. But they have very deliberately been very precautionary in Australia about invasion and have some of the best examples of why one should do that, I would say. So that's the Australian Weed Risk Assessment. It's pretty easy. And just as an aside, one of the very cool things after we started doing this work and publishing on it is the USDA Plant Protection and Quarantine Office that does risk assessment. It's their peril office in APHIS. They actually started looking at trying to use a more transparent, more quantitative approach for doing their risk assessment, and they based their new system, which is very good, on this Australian Weed Risk Assessment system. And they actually added some real improvements, I think, to the Australian Weed Risk Assessment. And so that's great that, in fact, they changed how they were doing risk assessment. So what the U.S.'s risk assessment for pests and plants also has this kind of a framework, although it's got more to it. The species that require further evaluation always give one heartburn. One really would like to resolve them into high or low risk categories. And as a result, Kurt Dollar and his colleagues from Hawaii published what's being called the secondary screen. And so for species in that evaluate further, that have the point scores between 1 and 6, you can ask just a small number of questions that you see here, and some of those species will turn out to be resolved into a low risk or a high risk category. What's interesting here, as you can see at the bottom, vines must pass both tests. So anything that makes a vine invasive like a tree or shrub or invasive like an herb means that it is likely to mean that vine might be invasive. So that's interesting. They put a sort of a stricter stipulation on vines than other growth forms. Another reason to think vines are ones we should be paying attention to. But all the results I'm going to show you for the Australian Weed Risk Assessment also include use of this secondary screen because it really does resolve a lot of the species, and in our test originally, quite accurately. So if you look at the question of how well does it do, and this is not just vines, this is our original work testing it in Florida, on the left side of your screen, on what would be the vertical first column, this is the status that species were assigned to. So they were assigned to major invader, minor invader, or non-invaders. And we used the IPC status assessment to do this categorization, as well as an assessment of weeds in agricultural areas in the southeast. Across the top is the results of the weed risk assessment. So if you didn't use any data from Florida and you just took these species at face value, what you know of them from elsewhere, would we have predicted them to be of high risk for invasion, of low risk, or require further evaluation? And just, I'm going to call your attention to a couple places. So these are the species that are the most harmful invaders, the species that we would all agree are really bad actors. And you can see that we predicted them without any information about the local sites 92% of the time correctly, with only 2% of the time being predicted incorrectly to be high risk. By the same, doing the same type of comparison, you can see the non-invaders, which we think should be low-risk species, were accurately predicted to be low-risk species over 70% of the time. If you look one column to the left, they're predicted to be high-risk species 8% of the time. So we have a higher false result for non-invaders than for major invaders, but not a huge one. And that's because a lot of the non-invaders were instead predicted to require further evaluation. So the jury's still out. And the truth is the jury is out on a lot of species that appear to be non-invaders right now. But so what we found was that we could accurately predict major invaders over 90% of the time, non-invaders over 70% of the time, and overall we had only 10% of the species after using that secondary screen that required further evaluation. And at the time, this was not different than, worked as well in Florida as it worked in all the other places that had been tested, and that was a great result to see. However, there's one complication with assessing accuracy using this kind of a data set, which is that what we know in the real world is we're bringing in, tens of thousands of species, and the vast majority of them are never going to become invasive. That is a very small proportion of species that might be introduced that actually become invasive. But in the test, you can see we had 62 major invaders. We only had 48 non-invaders. We didn't have this exponentially higher number of non-invaders in the data set as is in nature. And so the criticism is that the proportions of species testing the tool are not the same as the proportions of species that actually test it in reality that we are introducing. And one way around this is to use a tool that the medical field adopted. So I'm showing you just the data for Florida here, and if you just look at the histogram first on the upper right-hand part of your screen, and these are hypothetical data for non-invaders in the blue bars and for invaders in the sort of maroon bars, and what's on the x-axis is that point score from the weed risk assessment. And if we had a tool that 100% differentiated non-invaders from invaders, that would mean that the two histograms would show no overlap at all. And graphed on this receiver operating characteristic curve, that would produce a curve that would go straight up the y-axis along the correct rejection rate all the way up to 1, and then straight out parallel. I'm sorry, the incorrect rejection rate would be 0. That's why it would go straight up the y-axis. And then the correct rejection rate meaning we identified correctly a species was high risk, would be at 1, and that would go parallel to the x-axis. And that would be a curve with an area of 1. If these two histograms were 100% overlapping, meaning we had a tool that could not differentiate high-risk species from low-risk species, invaders from non-invaders, then the area under the curve would follow that diagonal line on the graph, and it would be 0.5. And what you see when we plot the real data here for Florida is that the curve more closely approximates that curve of 1 that I described, area of 1. In fact, it has an area of 0.9. And it's significantly different than no discrimination at all. So this is a tool that actually discriminates pretty well, regardless of the proportions of the species that are used for testing it. So that was really good news. And then the question became, is this, was it just our test, or is this everywhere it's been tested? And at the time we took everywhere we knew that had data that had been using this exact same tool for different locations. So you can see we have islands and continents, we have temperate and tropical in here. And right off the top, you can see that the curve areas are all roughly the same. There's a little bit of difference. They do interpret the questions a little differently, and we have tried to increase the consistency there. But the curve areas are about the same, and they're all at 0.9, which is nice. And in fact, they all essentially come up with the same prediction rates, that we are correct with high-risk species more than 90% of the time, and correct with low-risk species more than 75% of the time. When we're wrong with a low-risk species, it's predicted to be more invasive than it right now is appearing to be. That's a pretty precautionary approach. In other words, we're letting many fewer likely invaders in than we would be keeping them out if we were using this in a true prevention sense. So this is all background just to compel you to think that this is a tool that's pretty good. And one more piece of evidence there. Oh, sorry. And so what we concluded when we did all that comparison was that it's a tool that works very consistently with known accuracy, and consistently across a lot of very different geographies, which is important and useful for all of us. I'm going to stop and breathe and ask if there are any questions about that.
And Doria, they can ask questions in the box as they have them, and we'll answer them at the end.
Okay, I can't see the box since I'm showing you my full screen.
Right, I'll read them to you at the end.
Okay, great. Then I'll keep going. Thanks. Didn't want to be talking over someone who was dying to ask something. And one more piece of evidence that the results of this tool are pretty robust comes from a test from Singapore, which was very interesting, published in 2011 by Chong et al. And what they did is they took species that they knew were invasive or not invasive in Singapore, and instead of running the weed risk assessment themselves, they used the results for those species that had been run and the data were available from elsewhere. So they could use results from Pacific and Hawaii and the Pacific Islands. That's the first two lines, the solid line and the wide dotted line. From Florida in the narrower, more closely spaced dotted line, and from the Bonin Islands off of Japan. And they said, we're not even going to bother to run this tool ourselves. How well would it have distinguished the species that we know are invasive and not invasive in Singapore? And it actually works pretty well. Once again, we have these curves. They're about 0.9. I happen to be very proud that the Florida curve is the top one, meaning it matched, it predicted the best invasion in Singapore. And they concluded that you can use weed risk assessment scores from one location to make a quick cut on whether this is likely to be invader in another location. And of course, that only works if people put their data online, so you could actually do this kind of analysis. And there are a number of places where risk assessment data are online, and we're trying to get everybody to do this. What that means is even if you were going to do your own assessment, which we tend to do, you can start with somebody else's and then see what needs updating, rather than do all the research, look at all 49 questions right away. So just another piece of evidence that this is a tool that has I think of it as a very blunt instrument. It's not very sensitive to local environmental conditions. If you want to know something about a very narrow region, you probably want to modify it to really reflect that narrow region. If you're thinking about a country scale, especially a big country like the U.S., if we're thinking about prevention, then we have a broad range of environments. Even with climate change, these results are not going to change very much. Okay, so what actually did we learn about vines? So I'm just reminding you, these are the same hypotheses that I showed you earlier. The question was whether the tool was going to accurately predict what we see as the current status of climbing vine invasion in Florida, whether there's a growth form that's more likely to be invasive than others, and if time has any real component in this. In other words, how long a species has been in location, if that tells a lot of the story. So just to ask that first question, are there a high proportion of climbing vines that are invasive? And whether you look at the current status or you look at the weed risk assessment outcomes, that's what I'm showing in these two bullets, the majority of species are invasive and are predicted to be invasive. So once again, if we were doing this for a different growth form, we wouldn't expect this number to be so high. Climbing vines really do have a high proportion of invaders. Certainly we see that here, assuming that a number of different vines, and you saw before there are herbaceous ones and woody ones and perennial ones and evergreen ones and deciduous ones. We have a whole lot of different types of vines. They're not all imported for the same reasons, and still the majority of them seem to be invasive or have the potential for invasion. And then the question becomes, well, how well do we actually predict which of those species? Do we predict all 53 of those species that are invaders would be the invaders? And do we correctly separate out the non-invaders from the invaders? So the answer is not that well, which is disappointing. What is true is that there's no question that the scores, the weed risk assessment scores of invaders, that's the lower set of horizontal diamond shapes, and there's a lot of overlap of individual species on those diamonds, and that's why there aren't as many spots at points as you might think otherwise. But if we just have the weed risk assessment score along the x-axis, and we ask what's the distribution of scores for invaders and non-invaders, you can see that the mean score for non-invaders is significantly lower than the mean score for invaders. These are two different distributions. So one is at about 4, that's the non-invaders, and that's within that range that is between 1 and 6, if you recall. That's what I've highlighted in yellow, that range, which identifies the species that need further evaluation. And for the invaders, that red dot, which indicates the mean, is at 12, essentially. So the mean score is higher for invaders and falls squarely in the score range that would predict that they would be invasive. But there's a lot of overlap. So, and this was sort of surprising and troubling, and I'm going to show you this in a couple of ways. One is that if you look at the non-invaders, any point that is higher than where that arrow going down and hitting the x-axis at 6 is a species that's predicted to be at risk for becoming an invader. But we have a bunch of those that are non-invaders, right now at least. And if you look at the invaders, you can see that any species whose score falls below that yellow bar is predicted to be a non-invader. We don't have too many invaders, species that are currently invaders that are predicted to be of low risk for invasion. We have a bunch that fall into that needing further evaluation. But not surprisingly, because we know the accuracy of the tool, it does better at picking out and distinguishing species that are invaders from species that are non-invaders. But there's a lot of non-invaders that are predicted to be invasive, and there are two ways to interpret this. So I'm going to show you a little bit more data, go a little bit more deeply here. So we can do this with a chi-square kind of analysis as well, and say if we look at the risk that the tool predicts, which is the low versus high, versus the status of what we see in nature right now, non-invader versus invader, the tool does significantly show us that invaders are high-risk species more frequently than they're predicted to be low-risk species, and that that non-invaders, while more of them, 57%, are predicted to be low-risk species, a bunch of them are predicted to be high-risk species. So that could mean that there are a lot of species waiting in the wings ready to become invasive, and we ought to be watching carefully. And it could be that the tool doesn't work very well for vines, which have never been tested independently. Or it could be that the secondary screen, which I'm going to flip back for just a minute. Remember, all the species that fall within this area that overlaps the yellow area here are all species that fall in the needs further evaluation. A bunch of those we could then resolve to being either high risk or low risk by using that secondary screen. Remember, if you recall, it says vines must pass both tests, so we use that tool to resolve further. Maybe that secondary screen isn't so good. So the easiest thing to do would be to get rid of those species and say, what if we didn't resolve the ones that need further evaluation? Would this look different? Would it look significantly better? And the answer is it does look different, and it looks significantly better for the invader group, and it doesn't look so much better for the non-invader group. So that's just interesting, and I'm not going to tell you I have the answer to this yet. But the risk for us is that if this tool is at all accurate, there are a lot of species that right now look like they're non-invasive that might be becoming invasive over time that we should be watching out for. So one of the questions we then asked was, how time-dependent is the probability of invasion? We certainly know, the population growth curves show that species start small and then over time they grow exponentially. But is that evident from this data set of these vines? So what I've graphed here is for species that have been here essentially fewer than 25 years, all the way up to species that have been here for more than 100 years, in each of 5 blocks of time. If we look at the proportion of the species that have been here for that period of time, what proportion of those are actually invasive? What you can see is that there's a huge dependency. The longer the species has been in Florida, the more likely that group, the higher proportion of species that have been in Florida for that length of time are to be invasive. I hope I said that clearly. And this is the best data set perhaps I've ever worked with. I mean, this R-square is 0.96. This is a linear increase right now. And we just don't have much data. We don't have very many vines that we know of that have been in Florida for longer than 100 years. But it certainly does make the argument that a bunch of these species that have not been here for very long might actually be high-risk species for becoming invasive over time. So the question then becomes, which are those species, and can we learn anything useful? Can we think about them? Should they be the ones that we go after? As let's not wait and see if they might become invasive. They're predicted to be invasive, and they haven't been here very long. And that kind of a conclusion is strengthened because time explains the vast majority of the variance in invasion status. And unlike my hypothesis that woody species were more likely to be invaders, growth habit was not at all predictive of which species might become invasive. So what we would conclude from this is that, yes, a high proportion of vines are both predicted to be invasive and are invaders in Florida. Vines are an invasive growth form. That the predicted risk of invasion is reflected in the current invasion status, except that there are a number of species that seem non-invasive right now that are predicted to be at high risk, but certainly the species that are predicted to be at high risk for invasion are manifesting themselves. I didn't see any influence of growth habit on invasion, but there is a big dependency on time. Sorry, I didn't do my little checks in. So what does that mean? Well, for me, this is like one to really watch. So I think that's the utility of using a tool like this, a little more information so that we can potentially get ahead of some of the big problems. So this Dioscorea species, right now, and all the maps I'm going to show you are maps that come out of the flora of Florida's vascular plants. That's an online flora that immediately allows you to pull up a map like this that shows you that not the counties in which the species is present, but the counties in which the species has been vouchered. This is where we collected the data for how many counties is it in and how many collections, how many specimens from each county for identifying the invaders of disturbed areas and potentially agricultural areas. But you can see here's one that is predicted to be a high risk for invasion. It's been in Florida for less than 25 years, so it's a relatively new import. Our conclusion is it's not currently invasive, but given those pieces, if I had it on a piece of property I was managing, if I could afford it, I would go out and get it. I wouldn't wait to see. This is one that's a high risk, and it hasn't been here very long. It's on the very base of that curve that I showed you. And then we can look at a number of others. So here's one predicted to be of low risk in Florida. Sorry, by the weed risk assessment. It's been in Florida for less than 25 years. There's no evidence that it's currently invasive. You can see its distribution right now. This is the one I wouldn't spend my money on right now. That's putting a lot of faith in the weed risk assessment. But what we know is it doesn't miss a lot of high-risk invaders. Assuming it works well enough for vines, and this is something I'd like to look at even more closely, this is one I'd say, okay, given a choice, kill this one, and maybe leave this one be for now. Maybe it's not going to really go very far. What about some of the others? So, large yellow vetch in Florida for less than 50. Those are my only less than 25-year ones that came out that I wanted to contrast for you. I'm going to show you a few from less than 50 years. So here's one. We don't think it's currently invasive. It is predicted to be of high risk. It's only in a couple of counties. It's been here for under 50 years. This is one probably we don't have the resources for, but we should be watching it. And that's what I would do with a number of these others. Here's one that's very much used in the ornamental trade, so it's going to get further and further distributed. I would definitely watch it to see if it's coming into natural areas. This is a vine. It looks like it's the tree that's flowering, but it's the flame flower that's flowering. It's got essentially the same kind of distribution as the last one you saw. And once again, it's an ornamental. It has the potential to be spread around pretty rapidly by people. It's one to watch. And you can do this with any number of others. Here's an Ipomoea. You can see this doesn't look like it would be terribly aggressive, but it is predicted to be aggressive. Here's one that shouldn't surprise us. English ivy in Florida, not half as bad as in other places. Predicted to be invasive, a high risk. Already at least in North Florida in a number of counties. Just knowing how bad it is in other places is one we might want to get on here if we could still control it before it gets too out of hand. Here's a slightly more tropical one, Pothos. So all of these have the same profile, but they give us a sort of an early detection group that we could be watching out for. So here's another one, Madeira vine. That's in contrast to this one, Mamortica, which is really, I think, it's high risk, it's already invasive, it's only been here for less than 50 years. This is one I think is going to get much worse than other places should be looking for it too. So, just to kind of summarize where I am with all this, I think the reason for which weed risk assessment was invented was prevention, was to do a pre-border, do we let this species in or not? That's the most effective way, the most cost-effective way to address the invasive species issue, is to just not keep in the really bad, not let in the really bad actors. Once they're here, though, I think the weed risk assessment has utility, both in terms of species to watch out for early detection and rapid response, and for how we actually spend our management dollars, if you have some of those dollars that you can sort of use for trying to get ahead of some of the species that are just getting their foothold in our systems, that maybe we could actually get ahead of and eradicate locally if we actually knew they were ones we should be watching out for that had the potential to spread. And I think that these results could be used in all those ways. I hope I've given you some examples of species that would fall into those categories. So that's all I have, and I'm happy to answer questions.
Okay, we've got a few questions up there. One should be quick to answer is what species was before the Pyrostegia?
Oh, no. So you mean one that was pictured?
Yes.
So I should just go backwards?
Yeah. There. So
that's fun. The Brazilian joyweed alternanthera.
Okay. So one question asked earlier that I answered via the chat box was where the online publications for these webinars can be found, and I posted that for everyone. It's on the website for the National Association of Invasive Plant Councils, who is hosting the webinars. Doria, the first question, do you think the lag time has something to do with the overlapping WRA scores? Perhaps these need more time before they become invasive. So this was asked earlier, and I know you answered it during, but.
So I do. I think that, you know, some of these species are on the very beginning of their likelihood of spread, but we also know there are a lot of species that, you know, seem to be kind of benign mixers in. They never become dominant, that you find them sporadically. I don't think we should assume that every one of them is just low on the curve and is going to get to be a harmful invader. I think there are a lot of different environmental and biological factors that control the growth of populations, and that some of these species are unlikely to really become, you know, dominance, local dominance, and have real impact in our natural systems or in our agricultural systems.
Okay.
But certainly there is a time element there, and that's why I was sort of highlighting the ones that I thought, you know, haven't been in Florida so long. We ought to be watching those closest.
Okay. The next question says, are you able to scale species scores based on the number of questions answered? It seems if the minimum 10 questions were answered, one would be less likely to reach a 6 than if 49 questions were answered.
Yes, and that's true, although what we find out is that, and many people who have worked with this system have tested this, that the number of questions answered is not correlated with the score. Now, at the very low end of it is, of course, and you're totally right. But as long as you get to then, and we really do, we pretty much on average, we report it, and every time we write this up, you know, on average we answer at least 30 of those questions. At that point, the score is not correlated with the number of questions answered.
Okay. The next question is, there's an article in the current issue of Invasive Species Science and Management that questions the utility of weed risk assessment. Can you comment on their approach and conclusions?
This is, you're talking about the article that's by Smith et al. That it was in Invasive Plant Science and Management. That's what I think. I want to make sure that that is the question.
Is that
the article in question?
Doug, is that the correct article?
It probably is.
Okay.
And so the answer is, you really shouldn't ask me this. I'm way too close to this. I'm writing with probably 20 other authors. We're writing a rebuttal right now to that paper. And it's not that everything in that paper was wrong, and I think it's a very good thing to question the utility of all of these kinds of tools because they are all of them fallible. Unfortunately, the methodology that was used and even the number of the points of criticism so misinterpreted the methodology for weed risk assessment that's been published and is quite clear that the conclusions are not supported. That's my personal read on it. But I have a group of close to 20 international practitioners of weed risk assessment that are all in agreement that the methodology was really flawed.
Okay. Do you know when that article might come out, the rebuttal?
The rebuttal? You know how this is. I'm corralling 20 authors, and so we are on our. My guess is we're going to submit it in the next 2 weeks.
Okay.
How quickly the journal publishes it, we're putting it into the same journal, and it's going in as a very short. It is specifically a rebuttal, so it's going into an area they call the forum, which is for discussion. I'm happy to talk with anybody individually about specifics because there's very little we didn't put a lot of detail into the rebuttal, but it is really a shame that they didn't take a little more care worth that effort.
Yeah. Okay, the next question is asking what's being done with the species that are not invasive yet but have high risk to become invasive? So
nothing is what I would say, because we tend to react to the species that we know are a problem. None of us have the resources to, really get out ahead and say, wow, I haven't seen that before. By the time we actually notice something out in the environment, it's already fairly prevalent, which is why I was trying to go on the, maybe if it's only been collected in 5, from one location in each of 5 counties, that's something that's still fairly rare. But is obviously much more prevalent than we would like because most of us are not collecting herbaria specimen very frequently. So that's why actually I think this work is interesting because we could get a suite of species that is a suite we should be watching out for and potentially while you're out there with your Roundup, getting ahead of and asking the question later. Would this have been such a bad invader had we waited to watch it?
Well, and another good reason to do weed risk assessments so you know which ones those are.
Exactly, and that's why I tried to show you several at the end here. I think this does give us a few to look for. And it's not all 93 species that we looked at to start with. It's a finite number that have not been here very long, that are predicted to be high risk, that are already in several counties, but not yet very widely dispersed.
Okay. The next question asks, when you say that 100% of vine species that have been in Florida for 100 years have become invasive, are you talking about every non-native vine species in the state or ones that have been found naturalized?
So we should be careful. That's a good question. I'm glad you're forcing me to be careful. So this is of the 93 vines that we tested, all of which were non-native. But that's not every vine likely in the state. These are the ones that we could find records of. So first of all, there might be vines missing from that list. It's just that of the non-native that we tested that had been here for over 100 years, that's a small number. That's like 5 or 6 species. Every one of them was invasive.
The next question, is how to make certain that natives do not sell these invasive plants, and that's not really something. That's not really something that we're addressing here, but is really just to make sure that our representatives know how we feel about it and be sure they're well educated on the subject.
Mm-hmm.
Do you agree with that?
I do agree with that, and I do think that there are there are efforts like the Plant Right effort. There are a number of efforts out there that are really trying to work with the horticultural industry to get good understanding of species that maybe we would start avoiding. And some of these, perhaps like this one, I would just sort of start avoiding and say, what else can be a ground cover that has, nicely varied color and, would play the same role in the landscape but not be a high-risk species.
Okay. The next question, well, actually, I think it's more of a statement. It says the longest recorded lag time that they're aware of is 400 years from England for a native heath species. So I'm assuming that means it was there for 400 years before it became invasive.
Yes, so we don't have that data set, which is unfortunate.
Yeah.
Interestingly, Europe does, and there's a great study, a great paper, it's a book chapter by Kowarek, that documents it's a similar thing, that on average it takes well over 100 years for a woody species to demonstrate whether or not it's going to be invasive. And that's why, I'm going to go backwards so don't get dizzy, that's why this graph is so freakish to me, because we're only at the cusp of what these species can do. And that's really why I'm focusing on the short end of it, on the the less than 25 years, less than 50 years, because a number of these species are going to they're going to exhibit greater invasiveness than we see now. And if we could get a handle on some of them and get them out of our natural systems now, they won't pose so much of a threat later.
The next question asks, why were some scores negative on the vine figure?
So some scores are negative because for each of those 49 questions, if you recall, they have yes, no answers mostly, and there's a negative point score associated with a no answer, and a positive point score associated with a yes answer. And so if you add them all up, you're essentially balancing the traits that are less likely to be associated with invaders against the traits that are likely to be associated with invaders. And so those that don't have a lot of those traits are going to end up with negative scores.
Okay. And the last question at this point is there any correlation between the pending invaders and the EDRR list used by Florida SISMAs?
Well, interestingly, my invitation to come talk to all of you, which I appreciate, stemmed from a presentation I gave at the Florida EPC meeting this past spring. And in the room were the folks from the Florida Natural Areas Inventory that are working with the SISMAs to help them with their EDRR list. And they were all over this, and they came up to me afterwards and said, can we have your list? And I just gave them our data set. So the answer is yes, I do believe, because as you might guess, some of these species we only have records for them, for example, in the southern part of the state or the northern part of the state, as you could see on the maps that I showed you. And so they're important EDRR species for one SISMA and irrelevant for another. And that's how EDRR lists ideally are used, and is clearly how they're being developed. So the two Gregs that work on this with the Florida Natural Areas Inventory, working with the SISMAs, they're fully aware of this work and are starting to factor this work in.
Okay. And the last one, how does the Florida risk assessment address cultivars, or does it?
It does. This is part of the confusion from that article that I am writing a rebuttal to, which says that it doesn't. Very explicitly, you can assess any taxon about which you have sufficient information. So the biggest problem we have generally with cultivars is we don't know very much about them. They're a different color morph. We don't know what else has changed from the parent. And if you don't have that information, you have to assess the cultivar like the parent. But we actually have a protocol within the IFAS assessment that's on that website, the IFAS assessment website, that is explicitly, if you're working with a cultivar or a hybrid or some kind of subspecies level taxon, we call that an infra-specific taxon, to cover all of those without having to actually say them each time. You can run this specifically for that. So that's, in a whole other line of work I've been doing, I've been running this on biofuels, because I think that biofuels are our next big source of invaders, and particularly because we're planting, an individual or a very small number of genotypes over a very large acreage, and therefore really giving an opportunity for species to escape and become invasive. For those, the problem is that the cultivars are often, the information about them is proprietarial, and people don't really want to reveal a number of the traits that's important for us to be able to tell. But for those people who do, and for example, we've done the miscanthus, the giant miscanthus, which is a hybrid, and we've done the sterile giant miscanthus, and that is not predicted to be a risk for invasion. But once they have now bred fertility back into that giant miscanthus hybrid, it becomes an entity of risk for invasion. So you just have to have sufficient information about the subspecific entity to be able to do the assessment, and it works as if it were a full species.
Okay, thank you very much, Doria. We really appreciate you taking the time to share your research and your knowledge with us today. That was the last question.
Sure.
And we hope you were able to attend the next seminar.
Great. Well, if people have questions, please just give me a yell. This is a work in progress, but I hope is useful.
We'll be looking forward to seeing the rebuttal.
It's coming soon, I promise.
Okay, thank you.
Sure. Thanks very much. Bye.
Bye-bye.